Welcome to The Explainer. Today, we're going to dive into the Hugging Face Transformers library and turn a pretty technical guide into a simple, clear plan for fine-tuning models. The goal? To make the whole process way easier and a lot more powerful.
Okay, let's kick things off with something you've probably felt before. That frustration, right? The sheer amount of messy, boilerplate code, all the manual setup, the debugging, just to get a simple training loop to run. If you've been there, you know there's got to be a better way.
And guess what? There is. Here's our game plan for today. We're going to start with that fine-tuning headache, then meet our solution, the Trainer API. We'll walk through your first training run, learn how to actually tell if it's any good, and then we'll unlock some seriously cool advanced features.
Right, so first up, that fine-tuning headache. I mean, when you manage training manually, it's just a mountain of setup. You've got to worry about device placement, data loading, logging, and on top of all that, it can be painfully slow if you don't have a beast of a GPU. That's the exact problem we're here to solve.
All right, let's get into the solution. It's a fantastic little class from Hugging Face Transformers called, simply enough, the Trainer. The best way to think about it is as your automated co-pilot for the entire fine-tuning journey.
The best analogy? It's like having one of those super smart, automated kitchens. It handles all the tedious stuff, the oven temperature, the timers, the mixing, so you can focus on the fun part, the actual recipe. You just provide your model, your data, and your goals.
Okay, let's get our hands dirty. We're going to walk through our very first training run, and you'll see just how simple yet powerful this workflow can be. We're talking 4 clear steps to get from zero to a fully running fine-tuning process. First things first, we need a place to put all of our settings and hyperparameters. For that, we use the TrainingArguments class. Seriously, just think of this as the main control panel for your entire training job. And you know what's great? To get started, you literally only need to provide one thing, an output dir. That's just a folder where your model and checkpoints get saved. Everything else has these really sensible defaults that are perfect for getting off the ground.
All right, step 2, we need a model. For this example, let's say we're classifying pairs of sentences. So we'll use a model built for that exact task, AutoModel for sequence classification. We just tell it how many labels to expect, and the library does the rest.
Now, when you run this code, you're probably going to see this big old warning pop up. It'll say something about some weights not being used and others being randomly initialized. Don't panic. This is actually a good sign. It just means the model was smart enough to chop off its old, generic head and attach a brand new one, ready and customized for your specific task.
Okay, we've got our arguments, we've got our model, now it's time to bring it all together. We instantiate the trainer object itself, and we just pass it our model, our training arguments, and of course, our datasets.
And just look at how clean that is. The model, our settings, the data for training, the data for testing, it's all organized and bundled up in one place, ready to go.
And now for the best part. After all that neat setup, all it takes to kick off the entire fine-tuning process is a single, simple line of code.
That's it, trainer.train. You call that, and the magic starts. You'll see the training loss start to go down, step by step. But here's the catch. A dropping loss doesn't tell you the whole story. Does it really mean our model is getting good at the task we gave it?
And that is such a crucial point. We need to know if the model is actually performing well on real-world metrics. Things we can actually understand, like accuracy or an F1 score, not just getting better at making some mathematical number go down.
This slide just nails the difference. On the left, we're just watching the training loss. We're kind of flying blind. But on the right, by adding evaluation, we get real, interpretable metrics that tell us how the model actually performs on data it's never seen before. Now that's useful.
So, how do we get those awesome metrics? Well, we just need to create one little function. Its only job is to take the model's raw numerical predictions, they're often called logits, and compare them to the actual true labels from our dataset.
And we don't even have to do the math ourselves. We can use the fantastic Evaluate library to do all the heavy lifting. First, we load the right metric for our task. Then, inside our function, we just turn the model's logits into final predictions with Argumax, and then pass everything to the metric's compute method. It's really that simple.
Okay, so with our new evaluation strategy all set up, we retrain the model. But this time, we pass our new compute metrics function to the trainer. And now we can finally ask the most important question of all.
And there's our answer.
an accuracy of 85.78% on the validation set. Now that is a tangible, understandable number. It gives us real confidence in what we've just built.
So now that we have a solid, well-measured model, let's talk about training faster and smarter. That training arguments class is just jam-packed with powerful options. For instance, if you're on a compatible GPU, you can just set FP16 equals true. Boom! You've just enabled mixed precision training, which can slash your training time and memory usage. And that's just scratching the surface. You can control everything from learning rates to gradient accumulation.
So, to wrap this all up, what are the big takeaways? First, the trainer handles all the complex, messy parts for you. Second, training arguments is your central control panel for everything. Third, you have to use compute metrics to see how your model really performs. And finally, remember that powerful features are often just one simple flag away.
You know what this all really means is that the whole process gets reframed. This amazing tool handles the tedious, error-prone engineering, which frees you up to focus on what actually matters: your data, your model, and building something incredible.
So I'll leave you with this thought. With all this complexity handled so effectively, the barrier to entry is lower than ever before. Fine-tuning is now the easy part. So, what are you going to build first?